Good morning, good afternoon, good evening, wherever you may be, whatever time you may be watching this video. Today I want to talk about 8 inches per mile squared. What is that? Where'd it come from? How accurate is it? Well, I want to test that. So if you hang out just for a few minutes, I'm going to go a little bit slower, so all you math junkies, you already know this isn't for you. This is for everybody, boys and girls, young women, young men, all alike. People that haven't studied math in a long time, people that maybe haven't taken a lot of math. I, on the other hand, have taken a ton of math. I can't remember all of it because I just don't use it every day. But let's brush up on some concepts, shall we? I'm going to try this to make this short and sweet as possible, not to be too boring. But let's just hang out for a few minutes and let's talk about this. Let's talk about a distance, and this is going to be the distance in the beginning, but we're going to increase those distances to look at accuracy. 10 miles. So D is going to be a substitute for 10 miles in this overview. So 8 inches per mile squared. Let's go 10 miles. So 8 inches times 10 squared equals 800. But remember, we're talking about inches. So what does 800 inches look like? Well, let me get my ruler here. 12. No, mine only goes to 12. So 12 into 800, how many of those rulers? Well, let's check it out. How many rulers? Let's go 1 foot. Let's do a conversion method here. 1 foot divided by 12 inches is a fair conversion factor because 1 foot equals 12 inches, so we're allowed to do this. I am going to cancel inches, and I'm going to stick with feet. So we got 800 over 12 feet. Let's cross that T. What is that? 800 divided by 12 is going to give us 66.7 feet at 10 miles. We're going to come back to that, so keep in mind this is a magic number because we're talking about 10 miles. All right, let's talk about shapes. It's going to help us in our mathematical analysis here. Circle and right triangle. Circle. We got the center of a circle, or a ball, or a sphere, however you want to look at it. If we're talking about a circle or a sphere, let's say a sphere is floating in space and you're looking at it at a distance far, far away. Like, let's say you're looking at Earth from the moon.
This
just
is
be a
the
glowing blue ball, right?
Captured by the
Kaguya's
look like
HDTV because you really can't see the detail because you're so far away on the moon.
As the moon has no atmosphere, the outline of the slowly rising Earth is clearly
from
visible.
The center to the edge, any edge. And these edges are going to be exactly the same. That is called the radius. Now, what is it called when you go all the way around the circle? What is that length called? That is called the circumference. So when I say circumference, I'm talking about the length around the circle, around a ball, around a sphere. Okay, when I'm talking about the radius, I mean the center going to the edge, the radius. Let's talk about this special triangle. It's called a right triangle. Right meaning one of those edges is perpendicular. This means perpendicular. So this is also a perpendicular triangle. This is 90 degrees. A circle is 360 degrees. Now those are degrees, but what if we're talking about pi? Those are radians. A circle is what? 2 pi radians, right? So what is 90 degrees? Well, 90 degrees, that's going to be that much pi. So 90 degrees is going to be 2 pi divided by 4. That equals pi over 2, or 1/2 pi, however you like to look at it. Same thing. 1 times pi is pi. Divide that by 2. So when we're talking a little bit later, I'm going to mention that because it's kind of plays an important role when you're talking about making calculations, especially when you're talking about trigonometry. And we'll get into that. There we go. There's Earth. Object E.
The Earth came
when
into
we talk
view
about Earth,
above the
we're
moon's
going to talk about
horizon.
that radius starting from the center, right? The center out there, going that way. It's going to be the radius of Earth. Or we can call that radius. You're going to see me annotated that. That's a sub letter. R sub E, that means radius, Earth. Now let's talk about this triangle here for a second. Now, this is a special triangle. This is 90 degrees, or pi over 2 in radians. But it's a triangle, so it makes sense to talk about degrees. When you're talking in circles and spheres, it makes sense to talk about radians. We're going to talk about that here in just a second. As I promised, this is the hypotenuse side of a triangle. That's the opposite side of your right angle. This is your right angle, a 90-degree angle. Now you have another angle here. Now these angles can be the same or they can be different. This one, it's hard to tell, but let's say this is an angle and this is another angle. Well, my picture says that they're not necessarily the same. Let's look at this picture. Let's look at this angle over here. On the right side, let's call this angle theta. That's just a Greek letter that is pronounced theta. Now when we're talking about this angle, the opposite side is over here. When we say something's adjacent, we're talking about lying next to it. So that's going to be B. It's the adjacent side. The hypotenuse, remember when we were talking about that, is the opposite of the 90 degrees. And we just put this here so that way the reader knows, oh, this is a right triangle. Now, right triangles are special because there's a lot of things you can do with that. Let's talk about 8 inches per mile squared, but let's go a little bit further. I am going to draw a triangle, and I'm going to say, well, before I get into that, let's talk about lines. Let's say I draw a line, and I draw a super, super, super long line, like that. And I draw another line, and I'm going to say, these lines, that's a straight line, and here's another line. And I'm going to draw a line. Shoot, I don't know if I can keep my arm straight. Let's see how it's curved. It's actually squiggly, but let's pretend it's like a nice, easy curve. Like a curve you might find over here. So that's a quarter way around there. That's a long ways, but if you're a little tiny person, you can't even see it. You can't even see the curve, huh? Because you're on the Earth, and the Earth is so gigantic you can't see around that ball. You're right. You're a little tiny flea on this humongous planet. You can't see anything. You can't see a curve. You're just a puny little being. So this is the curve of the Earth right here, this arrow right here. It's so faint, you can't see it. So that's what I want to demonstrate. We're going to draw a triangle. Okay? And we're puny Earth people. So this person's going to walk out 10 miles. 10 miles. Of course, that's like a couple thousand miles, but let's just say, for this example, that's 10 miles. Now we're going to go from the radius, and we're going to draw it out here. Boom. And boom. So actually, this person walked 10 miles, D, distance equals 10 miles. And that's going to be our theme, okay? 10 miles. And we're going to say this is a right triangle. But this guy, he walked the Earth 10 miles. This is what he actually walked right there. But just for the sake of argument, let's say that yellow line is almost the same as this line. They're so close, in fact, because it's only 10 miles. Let's say they're the same length. So this guy walked 10 miles. He's actually walking this curve. Well, let's put him up here. Hi, everybody. I just walked 10 miles. And I deserve a cookie and a bottle of water. Let's talk about this angle down here. This angle, theta. Let's just call him theta. Let's call this side A. What did we call this? From here to here. What is that? Radius. Ooh, let's get some numbers on the board here. Circumference of the Earth, 24,881 miles. Radius of the Earth, 3,960 miles. We got numbers. They are proven scientific fact. Let's talk about where they came from, though. Let's talk about that just for a second. Circumference at the equator, sub E, is said to be 24,901 miles. Circumference of the Earth at the meridian is said to be 24,860. How do you take the average of two numbers? Well, you add them together, you divide by 2, and you get these averages. So coming from the circumference of the Earth average, you get also the average radius. So we're going to stick with the averages. Oh, the law of the averages. Okay, back to this program. So he walked 10 miles. We got the radius here, but what about this piece? What about this piece? Let's call that H. And if you forgot, let's remind you that this is the x-axis. That goes horizontally, left and right. All of these lines represent x, left and right. This line, this heavy line here, going up and down, this is the y-axis. Goes up and down. We're talking about this right triangle here. This special little triangle that we drew. We're saying this line is equivalent to this line, just about, right? That's what we were talking about there for a minute. How do we find H? Oh, I forgot to tell you here one thing. This is the radius. We already discussed that. This is also the radius, isn't it? You got the radius going this way, and you got the radius going this way. So let's find how far did he walk. We got something called the Pythagorean Theorem. And that says when you take a right triangle, A, B, C, that you square side A, you add it to side B squared. That equals to the hypotenuse squared. Well, let's check it out. Let's use substitution. A squared, looking at this diagram, A squared is R in our example. Side B, where we walked, let's call that 10. Call that D, distance squared, equals, Uh-oh, hypotenuse. What is that? Well, r plus h, isn't it? But they're together, so you got to keep them together. Let's put them inside that. R squared plus d squared equals r plus h squared. Well, what is that? What we're really interested in is h. H is how far did he walk in the y direction? How far did he walk? When he traversed the earth, going down, 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 10 miles, that's actually thousands of miles, right? 10 miles, it's a little tiny sliver up here, you can't even see it. That's why we're exaggerating. Totally exaggerating. That's why these lines are actually almost the same. So 10 miles. What is h? This is h. This is h right there, right? That little piece. So we have to isolate that. So let's take on the left side r squared plus d squared. Let's take the square root of that. And you know, you should remember, when you take the square root of a square, you're left with r squared plus d squared. That's root, but the square root of a square is just what's inside the parentheses. So furthermore, we're going to isolate h more. We're going to bring r to the left, r squared plus d squared minus r equals h. And that is your answer. That is how far he went down. So, how far was that? I preset the calculator, 3960. I stored that, I'll just do it again, into a variable, r, just like we did here. And I also took 10 miles, I stored that into a variable, d, just like I did here. 3960 miles, remember up here. And we're talking about d equals 10 miles in this example right here. So let's do it. What is that drop? What is that height? What is that y translation? Let's go square root of where is it? R squared minus d squared and parentheses minus r. R square root r squared minus d squared minus r. So he went down in the negative direction, 0.12626282 miles. Well, what do those kind of miles look like? I'm not really sure, but since the other example, 8 inches per mile squared was in feet, 66.7 times 10 squared over 12 equals 66.7 feet. Let's translate this times. We want miles on the bottom. How many miles? How many feet? Because we want feet here. 5280. 5280. We can now cancel these units, miles. We're left with feet, and that equals times 5280. And what do you know? there was a drop of 66.7 feet. It's the same. Well, 8 inches per mile squared must be the same, right? Well, that's what we're going to talk about. But let's go one step further. Remember this diagram? You can pause and come back anytime. I'm going to draw a new diagram. So let's call this number 1. Let's call this number 1 method, 8 inches per mile squared. Let's call number 2 the Pythagorean Theorem, 66.7 feet. Now let's go into method 3, and I call this the true method. Trigonometry. That's going to be fun. Now, how does this work? Now we're going to draw a little bit different, a diagram that's going to be a little bit different. Now, in this triangle, instead of drawing it on the outside, we're going to stick to the inside of the circle. And we're going to do it in this manner. He is going to traverse the circle. He's going to end up 10 miles over here. And like we already discussed, this is not to scale. That's thousands of miles, because 10 miles would be so small you couldn't even see it on this scale, because Earth is so big, especially in the middle of space. Looking at it from the moon, wow, what a sight. So, he walked 10 miles. He traversed the Earth 10 miles. Now we got a pizza. It's not a right triangle. Now what? We are stuck. Wait a minute. 10 miles right here. Let's do this. Let's draw a straight line. 10 miles all the way to the radius. All the way to the radius. Okay. Looks doable now. And I'll show you how that works. First of all, I need to break this side up. Remember, this is the radius here. This is also we're looking at this triangle here. This is also the long side, the hypotenuse, right? This is the radius, this is the radius of a circle, but I am going to get rid of this for a second. We know that's the radius. By definition of a circle from the center to the edge, they're both radius. They are both 3,960 miles from the center. So we're going to call this the radius. That is the radius from this point to the center point. But we want to look at this. Let's call this L, this piece right here. That's L. Let's call this piece H. We want to know the distance of H. Well, how are we going to do that? Well, that's going to be trigonometry, and this is really going to be really interesting, and at the very end of this video, you're going to see why I like to emphasize this one. Cosine. Let's also talk S. S equals arc length. That's a G. Arc length. So the arc length equals the radius of a circle times the angle radian. Okay? So when we're talking about traversing Earth, this piece of pie, 10 miles, the arc length is 10 miles. But what if we're talking about the arc length of the whole entire Earth? Let's look at S equals r theta. The arc length of Earth, if you're talking about the whole thing, the arc would be the circumference. And the circumference, the slice, the sliver, the slice of pizza would be 24,881 equals radius 3960 times 2 pi. Right? Radius times pi, well, let's see. Doesn't work out. My calculator is in radians mode. It's in radians either. So, 3960 times pi times 2. 24881.4182. They are the same. That's interesting. 0.41382. That number looks familiar. I wonder why. We'll come back to that. Okay. So arc length equals radius times theta. So we need to find h. So we're going to use SOHCAHTOA. Cosine theta equals the adjacent side over the hypotenuse side. Cosine theta equals, remember this is theta, opposite side, adjacent side, so lying down, it's going to be L. Oh, what's L? L equals radius minus height, doesn't it? The radius is the whole. L plus h equals r. L plus h equals r. L equals r minus h. L equals r minus h. Adjacent side, r minus h over hypotenuse, r. Solve for h. Cross multiply, r cosine theta equals r minus h. Solve for h. R cosine theta minus r equals minus h. Let's bring h to the left. Let's get rid of that minus sign. It's kind of ugly. H equals r minus r cosine theta. Let's bring out a factor of r. H equals r times 1 minus cosine theta. And that is theta equals solve for theta. S over r, right? 10 miles over the radius, 3960 miles, right? So let's bring out the calculator. R times parentheses 1 minus cosine 10 divided by, now we're in radians mode. If you're not sure, if you don't have a scientific calculator, remember to radians to degrees or degrees to radians. You take your number 10 over 360, 3960, multiply that pi over 180. That's your conversion right there. Just want to cover that real quick. But since my calculator here is scientific, it's in radians, does that internally, we don't see it. So what is this number? Look at that number. Didn't you see that earlier? Well, very, very close, right? Equals 0.0126265559 miles. Multiply that by 5280 feet over miles. Miles cancel. Multiply this by 5280. Look at that. 66.7 feet. Looks like they're all the same. But are they? Let's check it out. Number 3. We call this trigonometry. I'm gonna venture to say I think that's the best way to go. But who knows? Maybe it's an oblate spheroid. I really don't know.
When you spin pizza dough, it kind of flattens out. Yeah. It gets wider in the middle, and so Earth, throughout its life, even when it formed, it was spinning, and it got a little wider at the equator than it does at the poles. So it's not actually a sphere; it's oblate, and officially it's an oblate spheroid. That's what we call it. But not only that, it's slightly wider below the equator than above the equator.
A little chubbier.
A little chubbier.
Yeah.
Chubby's a good way. It's like pear-shaped.
Yeah.
Okay, so which method is better? Let's get into that. We talked about method number 1, 8 inches per mile square, but we're going to talk about Earth. So, our math check. This guy is going to start here. He's going to traverse the Earth all the way around until right here. This is the magic spot. So the center of the Earth, he's going to travel to the deep. 1 full radius down. That's how we're going to check it. So he's going to travel until he gets to here, and then he's going to fall off into the abyss, into this ice patch, onto Australia, something like that. Somewhere down there, right? Oh yeah, I forgot, but gravity. That's going to hold everything together. So using gravity, we're going to walk around this part of the Earth. Okay, here we go. So how far does he have to walk? We recall the average circumference of Earth is 24,881 miles. The radius of Earth average is 3,960 miles. Oh, remember when just a little side note, remember when we talked about the arc length equals the radius times theta, and we came up to 24881 equals radius times 2 pi, and we got a decimal. It wasn't exactly, these two multiply wasn't exactly 24881. Well, that's because they're both averages. This is an average, and this is an average. So when you they're called round-off errors. When you don't use the same calculations in both constant numbers, you're not going to get an exact match. That's why we had, bring my trusty calculator back in here. That's why we had 3960 times 2 times pi equal to that number. That's because 3960 was using a rounding or an average different method than the actual circumference. So that's as close as you're going to get for a fact check, if that makes sense. Okay, I digress. Let's move forward. Let's finish with this discussion. So, we are traveling 1/4 way around the Earth, and that's going to be our check. So, what is that number? It is the circumference of Earth divided by 4. It's going 1/4 around the way. 24881 divided by 4 is equal to 6220.25 miles. That's the distance we have to travel. Well, that's the distance this guy has to travel. Okay, 8 inches per mile squared. That's 8 times. This is distance times d squared divided by 12. Remember, that's going to give you feet. So we have to use a conversion factor of 5280 feet over 1 mile. 1 mile is equal to 5280, so this is a fair conversion. Let's plug in these numbers. 6220.25. Let's plug that into the new distance. It's going to be d. I can't remember if I saved r, but let's just do it. 3960 into r. That's going to be down here. Okay, we're ready to go. 8 times distance squared divided by 12. And when you do divide, the calculator knows it does it left to right evaluation. So 5280. This is totally doable. And this is your answer for equation number 1, the 8 inches per mile squared. If you traverse 1/4 around the weight of Earth, you're expecting to travel 3960 in the y direction. This is the change of y going downwards into the center of Earth. But we have 4,885 miles. Just keep it simple like that. So, using the first method, you're traveling 3960. You're traveling 1/3 of the down more. You're traveling past the mantle, past this boiling spot. So, for sure, traveling through the mantle, yeah, you're going to get burned up. So, not so accurate on big numbers. Little numbers, okay. We've seen that they all look the same using little numbers, right? 10 miles. Let's try the old Pythagorean Theorem. I've seen a lot of people say that 8 inches per mile squared comes from the Pythagorean Theorem. We're going to check that out. All right, Pythagorean Theorem says we do square root d squared plus r squared take that quantity minus r minus the radius r. Now we're keeping it there. We're not going to use this conversion over here because we don't want it in feet. We're fact checking now. We're doing a math check. So Pythagorean Theorem gives us 3,414, we're rounding, miles. Let's see, minus 3960. So that's going to bring us halfway down. That's going to bring us there. We still went a little too far. No, sorry. Didn't quite get in. So what about there? Not quite to the center. Just shy 500 miles. So there we go. So there's number 2. Here's number 1. What we really want is this line. This orange line right there. That's our target. Now, I was boasting that trigonometry should be the way. Let's check it out. So we got R times quantity, 1 minus the cosine, D over R. Because D now is 6220.25. And what do we get? 3960. 3960 miles. That looks pretty accurate to me. I don't know, you be the judge. So, going a quarter, we're fact checking, we are math checking, right? Version 1, the one we were speculating. We went 1,000 miles past our expected point. Method 2, 500 and something miles shy. Method 3, pretty much right, dead smack on. So there you go, there you have it. Information is power. God bless. Be safe.
La